Hello students, welcome to Marine Engineering Tutorials. I'm Atul Kumar Gupta and I'm back with a new tutorial. We are currently studying marine boilers. In this lecture, we will first learn about the Kangrim boiler which is commonly found on motor ships. Next, we will explore about the construction and operation of double evaporation boiler. Finally, we will study the construction and operation of Sunrod boiler, which has combined features of both smoke tube and water tube boilers. Let's now go through each of these topics one by one in the following slides. Kangrim boiler. This sketch shows a Kangrim tank type water tube boiler developed in Busan, South Korea in the late 20th century. It is one of the most widely used auxiliary boilers on motor ships. The boiler consists of a cylindrical shell with flat top and bottom. The cylindrical furnace is surrounded by water and has flat crown. The shell's top plating and furnace crown are secured together with several solid bars to prevent buckling. The bottom of the furnace is lined with refractory material to retain heat. Entry into the furnace can be made through the burner tube, which is connected to the outer shell where the burner is mounted. The boiler drum is equipped with two manholes for internal inspection, one on the top plate and other on each cylindrical shell. The bottom of the shell has several hand holes around the furnace for cleaning. The elliptical flue pipe is connected between the furnace crown and the top of the drum and passing through the water and steam space. The flue pipe has slight tilt which increases the surface area but can create blind spots that hinder effective water washing of the tubes. Several rows of water tubes are attached in the flue pipe which are slightly inclined horizontally, allowing the steam generated in them to rise into the steam space. Water level is maintained above the tubes to prevent their overheating. Steam is separated and collected above the water level. Flue gases, after transferring their heat to the water in the generating tubes, exit the boiler from the top. Kangrim boiler has working pressure of 6 bar, steam output 3000 kg per hour, feed water temperature 60 degrees Celsius, heating surface 38.6 meter square, fuel consumption 225 kg per hour, air consumption 3295 meter cube per hour at 45 degrees Celsius, flue gas volume 7508 meter cube per hour. Double evaporation boiler. The sketch shows a double evaporation boiler which uses the design of Foster-Wheeler D-type boiler with a steam heated steam generator drum mounted on top. The primary reason for this design is to allow the use of a modern water tube primary boiler on conventional oil tankers without the risk of feedwater contamination. Contamination can occur through a leaking tube or coil in cargo or fuel oil heaters, or from seawater during condensation of steam from a leaky tube. It uses a D-type primary boiler which consists of steam drum, water drum, and number of headers. Furnace of the primary boiler is surrounded by the water walls. Bottom of the furnace is lined with refractory to contain the heat. The furnace has double casing which helps to reduce the heat loss. Combustion air from the forced draft fan is supplied to the furnace through the double casing. As this boiler works in a closed circuit, it does not require continuous supply of feed water. The primary drum is initially filled with high quality feed water and treated with appropriate chemical dosing. Makeup water is supplied to the steam drum to maintain the water level when necessary. A small capacity reciprocating feed pump is sufficient for this purpose and no water level controller is required. Occasional testing of the boiler water is adequate to monitor its quality. The flue gases from the furnace pass through the generating tubes and exhausted through the uptake. A secondary drum is mounted on top of the primary boiler which supplies the steam for actual use. Secondary drum receives feed water from the inlet whose level is continuously maintained. Steam from the primary drum is supplied in the heating coil to heat the water in secondary drum and the condensate returns back to primary boiler. Combustion in the primary drum is controlled to maintain the steady steam pressure in the secondary drum. Thus, steam pressure in the primary boiler is not important, although safety valve is equipped for protection against high pressure. Secondary drum details. This sketch shows the details of a secondary drum in a double evaporation boiler. Typically, all mountings, including low water level alarms and low level shutoff systems, are installed on both the primary and secondary boilers. Secondary drum is mounted on the primary drum, whose important components are described here. Secondary drum shell is equipped with a U-tube heating element. The tube stack is supported in the drum and can expand on the free end. To ensure uniform distribution of relatively cold feed water in the secondary drum, the feed water supply is routed through an internal perforated feed pipe with a closed inner end. Steady water level is maintained in the drum to keep the heating coil covered. If the water level in the secondary drum drops, low water level trip stops firing in the primary boiler. The steam generated by the main or primary boiler is used to heat water in the steam generator or the secondary drum to get the required steam for actual use. Steam is supplied to the heating coil through steam inlet on the header and the condensate drains back to primary boiler. A vent is provided on the header to release air before starting the plant. The secondary drum is equipped with a scum valve internally connected with a scum pan located near the water level to remove any oil that may accidentally enter the system. Additionally, the drum is fitted with blowdown and sensing valves. Regular water testing and treatment are essential to control corrosion in the boiler shed. Saturated steam is taken out from the steam outlet valve. It is passed through the moisture separator to prevent carryover of water with steam. Safety valves protect the secondary drum from overpressurization. The pressure accumulation test for the safety valves fitted to the secondary drum are calculated with the primary boiler firing at maximum rate. Secondary drum is equipped with a feed water control and the combustion control in the primary boiler is dependent on the pressure required in the secondary drum. Secondary drum is equipped with a manhole for carrying out internal inspection or repair. The air vent equipped on top of the secondary drum is used to remove air while raising the steam from cold and to admit the air while cooling down the boiler. When secondary drum is used as steam and water reservoir with forced circulation exhaust gas boiler while at sea, primary circuit should be warmed up using simmering coil. Although this arrangement offers safety and reliability in operation on conventional oil tankers, extra cost and maintenance of the equipment overshadow the benefits. Therefore, it is rarely found on motor tankers. In addition to normal uses of steam on motor ships, this boiler is additionally used for heating the cargo, generation of inert gas, discharge of cargo using steam turbine driven centrifugal pumps, steam engine operated, stripping pump, and tank cleaning, etc. This boiler may typically have the saturated steam evaporation rate of 30 tons per hour at 16 bar. Steam pressure in the primary drum may range from 25 to 40 bar depending on the boiler firing rate. Sunrod boiler. This sketch shows the original design of the Sunrod boiler, which falls in the category of hybrid boilers, combining the advantages of both smoke tube and water tube boilers. Smoke tube boilers are valued for their simple construction and ease of operation, while water tube boilers provide a higher evaporation rate and can handle high pressure. Sunrod boiler was the first of its kind in this category, and similar designs have since been adopted by other manufacturers. These boilers deliver improved performance while retaining a simple design. Sunrod boiler was developed by Sunrod International AB in the early 20th century for marine applications in Landskrona, Sweden. Since 1991, Sunrod boilers are being manufactured by Albo Alfa Laval. Sunrod boiler is characterized by its large diameter Sunrod pin tube element. Sunrod boiler consists of a cylindrical drum with flat ends and has a vertical layout. It features a cylindrical furnace with disc ends supported at the bottom of the cylindrical boiler drum. The furnace crown is connected to top of the boiler drum by a small number of Sunrod pin tube elements. A Sunrod pin tube element consists of a smoke tube with a water tube inside. Pins attached to the water tubes increase the surface area, thereby improving heat transfer. The furnace is completely surrounded by water, eliminating the need for refractory material except for the burner coil. A burner is mounted at the burner tube which connects the furnace with the outer shell. Burner opening is also used as access to the furnace for internal inspection. Flue gases leaving the furnace give their heat to the surrounding water while passing through Sunrod pin tube elements, collect into the smoke box at the top and leave the boiler. Steam is collected in the space above the water level. A manhole is provided in the middle of the boiler shell for internal inspection and repair. A number of handholds are provided at the bottom for removing accumulated sludge from the narrow space around the furnace. The furnace is equipped with a drain to remove accumulated soot by hosing down into the Sunrod pin tube elements from the smoke box, which then flows to the soot drain tank. Sunrod boiler with improved design. This test shows a modern Sunrod boiler with an improved design. The furnace of the boiler is surrounded by water valves similar to those in large capacity water tube boilers, which make it gas tight. Bottom of the furnace is lined with refractory. A circular header at the bottom of the furnace, shaped like a ring, receives water from the steam drum through large bore downcomers to maintain water circulation. The water valves carry the water and steam mixture back to the steam drum. Since the ring header contains a small amount of water, boiler blowdown should be avoided while the boiler is firing, as it may cause temporary water starvation in the adjoining water valves, leading to overheating. For the same reason, if the exhaust gas economizer circulation pump is connected to the water valve header, the exhaust gas boiler circulating pump should not be started while the burner is firing, as it could disturb the water flow in the water valves. Within the boiler, the radiant heat from flame is absorbed by the water valves to generate steam. The flue gases then pass through the Sunrod pin tube elements where their convective heat is used to generate additional steam. Flue gases then leave the boiler from the smoke box. Saturated steam leaves from the top of the steam drum. Sunrod boilers are available in sizes ranging from 700 to 35,000 kg per hour with pressure up to 18 bar and are commonly used on conventional oil tankers for driving, cargo pumps, and for cargo heating services. In recent years, ships have begun using gaseous fuels in addition to liquid fuels. Boilers capable of utilizing both types of fuels are also classified as hybrid boilers. This completes our study of Kangrim, double evaporation, and hybrid boilers. This book has been written by me and covers all the topics as per the Indian Maritime University syllabus. It explains key concepts using simple illustrations. The book also includes answers to all questions that have appeared in examinations conducted by Indian Maritime University. It will help students prepare effectively for the exam and also support them in working safely with ships' boilers. I hope you enjoyed the lecture. Feel free to share your feedback in the comment section. If you found this tutorial helpful, consider sharing it with your friends. Subscribe to the channel to stay updated with upcoming tutorials. I will be back soon with a new lecture. Thank you for watching till the end.